Good day, students. Welcome back to the Algebra II CST review questions, part 2. In this clip, I'm going to be going over questions 21 to 40. This is a continuation of the other video. So, if you want to access this document I'm using right here, you can go to this link, www.ca.gov/th/tg/sr/css05rtq.asp, and it should give you a whole bunch of links, and you just scroll down to Algebra 2 and click on the document, and you have access to this document that I'm working on. Okay, I know there are two versions, but this is the updated version that they're for you. Okay, so let's start with question 21. You're supposed to find x plus 3 over x plus 5 plus 6 over x squared plus 3x minus 10. And now we need to find the LCD of these two denominators, okay, the lowest common divisor. This cannot be simplified any further as a prime binomial. This might be, so I might be able to factor this. Is this a multiple of that? I don't know. We need to factor this completely in order to be able to tell if this is a multiple of that and find the LCD. Okay, so let's factor this denominator right here. So let's factor x squared plus 3x minus 10. Anytime you have factorable polynomials in the denominator, trinomials do factor them. Okay, even though it's a binomial or a trinomial, always try and factor the denominators. All right, so let's factor this. I'm going to use the x method to factor this. AC is -10 and B is 3. What two numbers times to give you -10 and add to give you 3? I think 5 and -2, right? 5 minus times -2 is 10. 5 minus 2 is 3. So I'm going to put that in the center. X squared plus 5x minus 2x minus 10. All right? And then from the first two, I can factor out x, and I have x plus 5 left. And then from the next two, I factor out 2, and I have x plus 5. Notice when I take out this minus from this minus right here, it changes to a plus. Anytime you factor out a negative, the sign always flips to the opposite, okay? So I'm going to combine x plus 5 and x plus 5 into 1, x plus 5, into x plus 5. And then I'm going to be left with x, this one on the outside, x minus 2. So these ones on the outside, just combine them into 1, okay? So our problem now becomes x plus 3 over x plus 5 plus 6 over x, oops, I made a mistake here. That's supposed to be a plus. It's supposed to be a plus. X plus 5 times x minus 2. Okay? So now what's the LCD? We can basically see that the LCD of x plus 5 and x plus 5 times x minus 2 is x plus 5 times x minus 2. Okay? So I need to make both of them to have the same denominator. So in order to make them have the same denominator, or the LCD, I'll just multiply this by the missing component, which is x minus 2. So multiply this by x minus 2, top and bottom, so you do not change the problem. Okay? So that becomes, on the numerator, I'll have x. I can, so I'm going to have x minus 2 times x plus 3 plus 6. Since both denominators are now the same, I can combine them into 1. Okay, you don't add the denominators, you just combine them, right? Basic fraction rule. So x minus 2 times x plus 5. Alright, so we're going to simplify both the top and the bottom because that's what the options here calls for us to do. So let's just follow this out first outer, inner, last. So for this expression, I'm going to have x squared, and then times 3 plus 3x minus 2x plus 6, actually minus 6, because minus 2 times minus times positive 3 is minus 6 plus 6, and then that whole business, we do the same thing at the bottom. Let's distribute that. On the bottom, you're gonna have x squared. Does the bottom really matter in this problem? No, because all the denominators are the same, huh? So we don't even really have to do the bottom. We just need to focus our attention on the top. But let me just do it just for kicks, okay? So x squared plus 5x minus 2x minus 10. All right, let's simplify the top, which is what counts. On the top, I'm going to have x squared plus 3x minus 2x, which is positive x. And you can already see what the answer is. The answer is A. Okay? So the answer to number 21 is A. Alright, let's move on to question 22. Question 22, we have, alright, question 22, we have assessment of our knowledge of the law of exponents. So we have 3a squared b to the third c to the negative 2 divided by a to the negative 1 b squared c, all that raised to the third power. Okay? So remember, in the order of operations, parentheses comes before exponentiation. So we must resolve this parentheses situation in the denominator first before we go ahead and solve and use the law of exponents. Okay? So in the denominator, I'm going to distribute this 3 to all of this. This has a negative 1, this has a 2, this has nothing. So put a 1 here. Okay? So I'm going to go 3 times 1, 3 times 2, and then 3 times negative 1, like that. Alright? So that gives us 3a squared b to the third, c to the negative 2. And then in the bottom, a to the negative 3, b to the sixth, c to the third. Okay? Now to simplify this, the next step, I don't like negative exponents, okay? So to resolve the negativity of the exponents, I'm going to reciprocate any negative exponent. So when an exponent is negative on the top, it comes down. If it's negative on the bottom, it goes up. Okay? So 3 is good. A has a positive exponent, so let's leave it alone. B to the third is positive, leave that alone. This is ill, because it has a minus, right? So it needs to go downstairs. So we're going to have C squared. Okay? A to the negative 3 needs to go up. A to the third. And then b to the sixth is good, that stays down. And then c to the third, that stays down. Okay, so note that this one went up and this one came down. Alright, so let's combine it. So we're going to have 3, and then a to the third times a to the second times a to the third is a to the 2 plus 3. Remember the rule of exponents? Anytime you multiply, you add the powers, right? So if you have multiplying exponents with the same base, you add the powers. So these two are the same, that's why I'm adding the powers, okay? And then b to the third. And in the denominator, b to the 6 stands alone. And then what do I do with the c's? Since they're the same base, you add the powers, 3 plus 2. Okay? So that gives us 3, a to the 5th, b to the 3rd, over b to the 6th, c to the 5th. Alright? So there you have it. Now, to finish this off, we need to see if we can combine any like bases, exponents with like bases. So, if you look at it, 3 is by itself. A to the 5th has nothing to be combined with, so let's leave it alone. Now look at b to the 3rd here and b to the 6th here. These two can't have been divided. So anytime you divide, you subtract, okay? Well, you always subtract the smaller one from the bigger one. So since the bigger one is downstairs, it's the ruler, it's above, right? So the small one upstairs has to come down and subtract from that power right there from c to the 5th. Alright, and then your answer is going to become 3a to the 5th over b to the 3rd, c to the 5th. Okay? And your answer for 22 should be A. Okay? Alright. Let's move on to question number 23. Alright, so for 23, like I told you, I like to resolve negative exponents first before I do anything. Okay, so if you look at this problem, you notice that we have negative exponents, so I like to fix that first. So let's write down the problem. 20x to the negative 4 over 27y squared divided by 8x to the negative 3 over 15y to the negative 5. Okay, so now this x has a negative exponent. It's ill, so it needs to go downstairs, right? So we're going to have 20 on top divided by 27. Now the x comes down and it becomes positive. It's no more ill because it's switched. It was reciprocated, and then y squared divided by this x to the negative 3 is ill also, so I need that minus to switch it to the bottom. Okay, so I have 15 x to the third. It's now positive since it came down. This y is also ill because it has a minus exponent, so it needs to go upstairs and become, well, or positive, like that. Okay? Now what does divide mean? When you're dividing two fractions, it's the same thing as multiplying by the reciprocal of what you're dividing by, right? So I'm going to rewrite this one. Just bring this down, change this division to times, and I'm going to reciprocate this. Okay, so bottom goes to top, top goes to bottom, like this. It's y to the fifth. Okay? So you can multiply across and reduce, or just cross reduce, whichever method works best for you. You can go ahead and employ that. Okay, I'm going to use a really, really elementary method. I'm going to break down the numbers and then help you see what I'm doing reducing. Okay, so basically, let's see. 4 goes into 25 times, and 4 goes into 8 twice. Any common factor with 15 and 27? Yeah, 3. 3 goes here, 9. And then 3 goes here, 5. Okay? When you multiply across, you're going to have 25 x to the third in the numerator, because 5 times 5 is 25 x to the third, divided by 9 times 2 is 18, x to the fourth, y to the second, y to the fifth. Okay? Alright, that's now going to become 25. Now you see that, you notice there's an x to the third here and an x to the fourth on the bottom. This one is smaller, so we're going to subtract it from the bottom. Okay, so 18. This one is the boss because it's bigger. So 4 minus 3. And then what about the y? Since the bases are the same and you're multiplying, what do you do with the exponents? You add, right? So 2 plus 5. So it's going to become 25 over 18 x y to the 7th. Okay? Alright, so what is the answer? The answer to that is D. Alright, let's move on to question number 24. Question 24, it says, which product is equivalent to that? So let's take a look at that. 24. We have 4x squared minus 16 divided by 2 minus x. So can I factor the numerator? So let's see. I want to extract the numerator and see if I can factor it. So numerator. The numerator is 4x squared minus 16. If I break this down, it's 2 times 2 times x minus, if I break down 16, it's 2 times 2 times 2 times 2. You can just use a factored tree to break it down, right? 2, 8, 2, 4, and 2, 2. And you have all those business, okay? Alright, so that's how I did it. So what can I factor out? I have a 2 here and a 2 here, a 2 here and a 2 here. That's it. So I can take out a 4. And if I multiply what's left, I have x squared minus 4. Okay? Now, can I factor x squared minus 4? Absolutely. There's a formula you know called the difference of squares. A squared minus b squared is what? C squared? No. That's what people like to say. I don't know why people say that. But a squared minus b squared equals a plus b times a minus c, yes? How did I get that? You just simply square root the first and the last, plus or minus. That gives you that. Okay, so in this case, this is going to become, I'm going to square root x squared to get a, and square root 4 to get b, right? So it's going to become 4 times x plus 2 times x minus 2, okay? If that doesn't make sense, look here. A is equal to the square root of x squared, which is x, okay? And then b is the square root of 4, which is 2. Okay, and then just plus or minus both of them, just like the formula is asking us to do. Okay, so that goes the numerator. The denominator is not in standard form. Is a 2 minus x. So subtraction does not commute. Subtraction commutes with its opposite. So if I switch the order of this is going to become negative, parenthesis, x minus 2. So don't forget, anytime you switch the order of negative, you have to indicate it becomes the opposite. Okay, so subtraction commutes with its opposites. Okay, so this goes in the denominator, and this goes in the numerator, this one, and this goes in the denominator. And let's see what cancels out. Okay, so we bring them together. We have 4 times x plus 2 times x minus 2 divided by negative x minus 2. Okay, so what happens here? These two are like, so this and this cancel out, and then you're left with this minus over plus on the top is minus 4 times x plus 2. Alright, so for number 24, your answer is C. No, I'm sorry, D. The answer is D. Okay, so don't forget, anytime you switch the order, you always have to put a minus there. Okay, if you didn't, you would have got the wrong answer. You would have got B as the answer. Alright, now let's move on to question 25. Alright, so let's see. For this 25. Oh, okay. Let's take a look at this one. So for 25, we have x squared plus 4x divided by x plus 3 times x squared minus 9 divided by x squared plus x minus 12. Okay, so we're going to have to factor 1, 2, 3, 3 times, okay? So I'm going to name them. Let's call this the upper left, and let's call this the upper right. Let's call this the lower left, and let's call this the lower right. Okay, so I'm going to factor each and every one of them, and then I'm going to bring together all the factored forms and see what cancels out. Okay, so let's start with the upper left. Upper left, we have x squared plus 4x. Can I factor this? So let's break it down and see, okay? So I have x times x plus 4 breaks down into 2 times 2 times x. What can I factor out of here? I can take out an x and an x. So I have x, I have x times x plus 4. Okay, this is the completely factored form of the upper left. Now let's take a look at the lower left. The lower left is x plus 3. Guess what? That's the factored form. There's nothing else I could do to that. It's prime, okay? Now let's look at the upper right. The upper right is x squared minus 9. You know what this is? It's a difference of square. This is a square, that's a square. We're using the formula a squared minus b squared equals a plus b times a minus b. You just root the first and the last and then plus or minus, and then you get that, okay? So if I want to factor this, I can root this and root that and then do plus or minus, okay, to get my a and my b. So my a is basically x and my b is 3, right? So plus and minus down. That's how you factor out the difference of squares. I hope that makes sense, okay? So a is the square root of the first, b is the square root of the second. Now for the lower right, we're going to factor that completely. We have x squared plus x minus 12. I'm going to use the x game for this one, okay? So let's make the x. AC goes on the top, b goes on the bottom. AC is negative 12, and then b is 1. What two numbers times to give you this and that to give you that? I believe 4 and negative 3 will work here. So let's put that in the center. X squared plus 4x minus 3x minus 12. From the first two, I can take out x, and I'm left with x plus 4. And then from the second two, I take out 3, and I'm left with x plus 4. So that gives me x plus 4 times x minus 3. So that is my lower right. Okay, so I'm going to put the, what I just did. I'm going to put together all the results I got, and then see what cancels out. Okay, so upper left, I have x times x plus 4. Lower left, I have x plus 3. Upper right, I have x plus 3 times x minus 3. In lower right, I have x plus 4 times x minus 3. Okay, so let's see what cancels here. So we have this one cancels out with that, which is good. We're left with 1. This one goes into itself once and goes here once. This one goes into itself once and goes here once. You're left with x. So your final answer to this problem is just simply x, okay? Alright, now let's move along to question 26. It says, what is the simplest form of this whole 9 yards right here? 5x to the third, y plus 20 x squared y squared plus 20xy to the third divided by 5xy. Okay, whenever you're dividing by something like this, you can divide every single term by that common denominator, right? So you're going to have 5x to the third y, divide that by 5xy. plus 20x squared y squared. Divide that by 5xy. And then you have 20xy to the third. Divide that by 5xy. Okay? So let's do the first one. 5 divided by 5. 5 goes here, 1. 5 goes here, 1. And then you're going to have x to the... how on earth do we do this? This has no power, right? So just 1, right? So it's x to the 3 minus 1. Okay? Always minus the small one from the bigger one. Y's and y's cancel out because they're identical. Plus 5 goes into self ones. 5 goes here 4 times. 4. The x's, this has no power, so put a 1 here. This has no power, so put a 1 there, okay? So since the one on the top is bigger, it's the boss. So it's 2 minus 1. And then this one on the top is bigger, so it's the boss, 2 minus 1. Plus. And this side, 5 goes here 1, 5 goes here 4. 4. The x's are the same, so they cancel out. This has no power, put a 1. So you have y to the 3 minus 1. Alright? So let's simplify this. We're going to have x squared plus 4xy plus 4y squared. Okay? Alright, what's our answer? Oh boy. It doesn't match any of this. So that means they want us to factor this. Okay? So let's go ahead and factor it. We make an x. Use the x factoring method for this. AC goes on the bottom, basically the coefficient of the variables of the first and the last, and then B goes on the bottom. AC is 4, B is 4. Numbers that work 2 and 2. So we're going to have x squared plus 2xy plus 2xy. I got this coefficient from here and here, basically go in the center. You know what, let me color code it so that you guys can understand what on earth I'm doing. So 2xy, no, 2 blue, xy, okay, plus 2 in blue, and xy. You know where I got those two 2's from? I got it from here, okay? Plus 4y squared. Now from the first two, I can factor out x, and I'm left with x plus 2y. From the next two, I can factor out 2y, and I'm left with x plus 2y. Alright? So these two that are identical, these two identical quantities in the parentheses can be factored out into x plus 2y. And when they're factored out, you'll be left with x plus 2y, and you can put that together. Okay? Now, since the two quantities are identical, you can write them as a square, x plus 2y, because it's been multiplied by itself. Final answer is B. Okay? Alright, let's move on to question number 27. Alright, so let's look at 27. We want to multiply here. I don't know if anything is a factor of something else. If any of the numerators have a common factor with any of the denominator expressions, write down the question. 2x squared minus 10x divided by x squared plus 8x plus 16 times 4x plus 16 divided by x squared minus 25. I don't know. Are there any common factors here? It's hard to tell, right? So what I'm going to do is I'm going to label them, and I'm going to factor every single one of them down, okay? So let me call this my upper right. Call this my lower right. Call this my upper left. And then call this my lower right. Oh gosh, I don't know my left and my right anymore. Where is my right? Where is my left? Gosh, I'm confused. Okay, this is my right. Right here, I'm sorry, I get confused with my right and left all the time. And this is my left. Okay, I think I got it now. Now this is my upper left, and this is my lower left. Alright, now I'm going to factor each and every one of them. Okay, so let's start with the upper left, or my numerator to the left. Upper left is 2x squared minus 10x. So let's break this down. It's 2 times x times x. 10 breaks down. The prime factorization of 10 is 2 times 5 times x. What's common here? Notice that 2 is common, and also x is common. So why don't we factor that out? Okay, so we have 2x times x minus 5. So this is the prime factorization of this one, the complete factorization of the upper left. Okay, so the denominator on the right, on the left or lower left, LL. We're going to be factoring this trinomial x squared plus 8x plus 16. To do this one, I need to use the x scheme, right? I want to factor these by grouping. So let me just make an x right here real quick. AC goes on the top. b goes on the bottom. What two numbers add to give you this and times to give you that? 4 and 4 will suffice. So I'm going to have x squared plus, I see this 4 right here, I'm going to write 4x plus, you see that 4 there? Plus 4x plus 16. And I'm going to factor by grouping. From the first two, I'll take out x, I'll have x plus 4. From the next two, I'll take out 4, I'll have x plus 4 also. Alright? Now the quantities in parentheses are identical, so I'm going to factor them out because they're common factors. X plus 4. And then you're going to be left with this and that right there, okay? X plus 4. These two quantities are identical, so I can express them as a square since it's being multiplied by itself. So x plus 4 squared is my expression for the lower left. Alright? Now let's do the upper right. Upper right on my numerator to the right. So that one is 4x plus 16. Let me break it down first. It's 2 times 2 times x, and then 16 breaks down into 2 times 2 times 2 times 2. Alright, so what's common here? You see 2, 2, 2, and then 2. So I can take out 2 2's, which is just 4, right? And then I'm left with x plus 4. And this is a complete factored form of the upper right. Alright, now to finish it up, we're going to do the lower right, and then we see what cancels out, okay? So the lower right is x squared minus 25. What on earth is this? There are no common factors, right? Since this is a square and that's a square, it's a difference of squares, right? So we're going to use the formula a squared minus b squared equals a plus b, a minus b. And how did I get that? You just read the first one and the last one and then plus or minus. So that's what I'm going to do here, right? Read this and then plus or minus, right? So if I do that, my a is going to be x and my b is going to be 5. Let's write it twice, because you have a, b twice. Plus, minus, there goes the factored form. Okay? So let's put everything together, and then we're going to see what cancels out. Alright, so times, my upper right is 4 times x plus 4. My lower right is x plus 5 times x plus 5. My upper left is 2 times oh gosh, I can't even see it. Let me go up. Upper left is 2x times x plus 5. So let's put that down. 2x times x minus 5. And then on my lower left is x plus 4. Let me write it as x plus 4 times x plus 4. Okay, write it out like this so I can see what cancels out. Alright, so let's see what cancels here. I can't see any that cancels out because I made a mistake. Alright, if you notice the lower right is x plus 5 times x minus 5. Alright, sorry about that. X plus 5, x minus 5. Okay, so this cancels, goes into self once, goes here once. X plus 4 goes here once, x plus 4 goes here once. Now when you multiply what you have left, in the numerator is simply 2x times 4, which is 8x. It's not divided by the denominator, which is x plus 4 times x plus 5. Final answer is C. Okay? Alright, let's move on to question 28. Question 28. You're asked to divide those two. So we're going to have 4 times x plus y divided by 5x squared y to the third times negative 2x divided by negative 2x minus 2y over 10. Okay? Now what does divide mean? If you're dividing two fractions, it means you multiply by the reciprocal of what you have on the right. Okay, so you just drop the top down, this side down. 4 times x plus y over 5x squared y squared, y cubed. Change your divide to times and then you flip this over. So you're going to have 10 over. Now what if I factor out negative 2 from these two? If I factor out negative 2 from x, I'm just left with x. If I factor out negative 2 from negative 2y, I'm left with positive y. Don't forget, anytime you take out a minus, you factor out a minus, the signs flip, right? Because minus switches the sign. Okay, so this was a negative before, it becomes positive. This is a minus, this becomes positive. Okay, so let's see. Oh, x plus y goes here once, x plus y goes here once. 2 goes here once, 2 goes here 5 times, 5 goes here once, and 5 goes there once. Alright, so you're going to have 4 on the numerator over, don't forget this minus, okay? That's a trick. Minus x squared y to the third. Alright, so your answer is going to be, for 28, your answer is going to be A. Okay? Alright, now let's move on to question 29. 29 says, if I is the square root of 1, which point is 5 minus 2i? So for 29, 5 minus 2i. So for this one, just remember that the real part is the x and imaginary part is the y, okay? So basically, which of these points is 5 comma negative 2? Okay, because x is 5 and y is negative 2. So which point is 5 negative 2? You just go to the right, 1, 2, 3, 4, 5, go down 1, 2, bam, there goes your answer. Your answer is point D. Okay, and which one is point D? Oh, option D is point D. What a coincidence. So this is your answer, okay? Alright, let's move on to question number 30. Question 30, it says what's the value of I to the fourth if I is square root of 1? So question 30. I is the square root of negative 1. So what is I to the fourth? Let's see. I to the fourth must be this 4 times, right? So negative root 1 times negative root 1 times negative root 1 times the square root of negative 1, root negative 1, okay? So these two together is going to give you negative 1, the square root of negative 1 squared, right? Times, these two together is going to be the same thing, the square root of negative 1 squared, okay? So on the left side, the square and the square root cancel. This one, the square and the square root cancel because they are inverse operations. So you're going to have minus 1 times minus 1, which is 1. And your answer for number 30 is C. Okay? Alright, let's move on to 31. 31 says, what complex number is represented by the points on the graph below? So remember what I told you? For complex numbers, is basically x plus yi, right? So whatever the point is, the x coordinate is the real part, the y coordinate is the imaginary part. So if you look at this point right here, this point is 3 comma negative 4, okay? This part is the x coordinate, which is the real part, and this is the y coordinate, which is the imaginary part, okay? So if I want to put it in this form, I'm just going to have, if I want to put it in x plus y I form, I'm going to take the x coordinate and plug it in here, 3 plus the y coordinate, negative 4, and plug it in for the yi, and you're going to have 3 minus 4i, okay? And that is option C. So number 31, your answer is C. Alright? Okay, now let's move on to question 32. Question 32 says if I equals the square root of 1, what is 4i times 6i? So for 32, it says what is 4i times 6i? So 4i times 6i, 4 times 6 is 24i squared, right? So it's going to be 24. We know that I is the square root of negative 1. If I plug it in here, I'm going to have the square root of negative 1 squared. Okay, because I is the square root of negative 1. So when I plug it in here, I'll just substitute I with square root of negative 1. Now, since square and square root are opposites, these two cancel out. So you're going to have 24 times negative 1. And the answer is negative 24. Okay, so what I'll need you to remember is that I squared equals negative 1. Okay, it's always the opposite of the number. Alright, so for example, 5i squared is going to be negative 5. Negative 6i squared is going to be 6. Like that. Okay, so I squared is just changes the sign. That's what I squared does. So you notice I squared changes 24i squared into negative 24. That's what it does. Okay, so the answer for 32 is C. Alright, now let's move on to question number 33. Start this. Alright, so 33, it says, which is the equivalent form of 2 over 3i? So you may not have an imaginary number as a denominator, okay? Just like you can have square roots in a denominator. You can have a complex number, imaginary number as a denominator. So what you're going to do is we need to rationalize, you multiply by the conjugate, okay? The complex conjugate, right? Complex conjugate is what you get when you take the opposite of the imaginary component, okay? So we're gonna multiply by, what's the opposite of positive I? Minus I. 3 times negative I over 3 times negative I, okay? So if you distribute the top you're gonna have 6 minus 2I, and on the bottom, you're gonna have 3 times 3 is 9, 9 minus 3I plus 3I, minus I squared. Okay, so you're going to have 6 minus 2I divided by 9. You see these two here are opposites, right? So they basically cancel out. And then remember what I told you I squared does? It just changes this sign. Okay, so I squared is negative 1, so it's going to be 9 minus I squared is going to transform into negative 1. Alright? So it's going to become 6 minus 2I divided by 9 plus 1. Okay? So it's going to be 6 minus 2I over 10. Now I can divide everything by 2, right? Because 2 goes into everything. I can divide that divided by 2, this one divided by 2, this one divided by 2, or use everything by 2. So if I divide everything by 2, I'm going to end up with 3 minus I over 5. Okay, so the answer here is B. So you notice how in this I squared there's like a 1 here, like an imaginary 1. Like a 1 right here. So what this I squared does is it changes this minus 1 into plus 1, and it's added to the 9, which gives you 10. If you made a mistake and left this as a minus, you get 8, and this would be 4, and you'd fall in the trap of selecting a wrong option. Okay? So be careful. I squared switches the sign to a positive. That's why I have 9 plus 1 equals 10. Alright, so the answer is B. Okay, let's move on to question 34. Question 34 says, what is the product of 3 plus I and 3 minus I? So this is just like distributing binomials, like a foiling, right? So all you just do is just distribute first, outer, inner, last. And remember that I squared is negative 1, okay? So when we do that here, we're going to have 3 times 3 is 9. 3 times I, negative I is negative 3I. I times 3 is positive 3I. And then this one is going to be negative I squared. Okay? So you're going to have 9. These two are opposites, so they cancel out. This I squared is going to become what? Negative 1. Alright, be careful with that. So you're going to have 9 plus 1, which is 10. So the answer for number 34 is B. Okay? Alright, let's move on to 35. Question 35. It says if I is equal to the square root of negative 1 and B are non-zero real numbers, what is 1 plus A plus BI? Now in this question, what's the problem here? Remember, you cannot have an imaginary number or a complex number with an imaginary part in the denominator. You can have imaginary part in the denominator. So this imaginary part here is a problem. So to get rid of that, we need to multiply by the complex conjugate. Okay. Remember how to get the complex conjugate. You just take the opposite of the imaginary part. Okay. So this is plus vi. So I need to multiply top and bottom by a minus vi. On the top and on the bottom a minus vi. All right. So when I distribute on the top, I'm going to have a minus vi. And then denominator, I'll multiply the a's. You have a squared minus ABI plus ABI minus BI, B squared, I squared. Okay, because B times B is B squared and I times I is I squared. So we're going to have A minus BI divided by, now I see these are opposites, they cancel out. You're going to have A squared. Now this I squared is simply going to change this sign to a negative half, because I'm going to write this as B squared, and then that I squared is negative 1. Put it in red so you can see. Negative 1. Don't forget that. And now that becomes a minus bi over a squared minus times minus plus b squared. That goes your answer. Your answer is B. So the answer to number 35 is B. Okay? Alright. Now let's move on to 36. It says which expression represents negative 3 minus 2i subtracted from negative 5 plus I. Okay? Now what I like to do is I like to change my subtraction problems into addition by adding the opposite. So I need to take the opposite of this side right here by distributing this negative to both of them, okay? So I'm going to drop down the left side, negative 3 minus 2i, and then distribute minus times minus is a plus, plus 5, and then minus times plus is a minus, minus I, okay? Alright, if you like, you can put the invisible one there if that makes you happy, alright? So, negative 3 plus 5 is 2. Subtract, keep the sign of the bigger one. These are the same sign, so you add and keep the sign, 3i. So 2 minus 3i, answer to number 36 is there. Alright, let's move on to 37. 37, it says, what is the sum? What on earth does sum mean? Sum basically means you have to add, right? So we're adding these two. So let's line it up, real part first and then imaginary part second. And then negative 3 plus 4i. And add downwards, you're going to have 9 minus I. Okay? So the answer to number 37 is A. Alright. Now let's move on to question number 38. Question 38, it says, what are the solutions to this equation? 38, you have x squared plus 2x plus 2. It looks like I might have some complications here. Let's see if the x game works. Okay, if the x game works, then my answer should be 8. If not, we have to do something else. So we have 2 and 2. What two numbers times to give you 2 and add to give you 2? I know 2 is 1 times 2, right? But this number adds or subtract to give me 1 over 3. And that's not what this is. So I'm out of luck. The x game doesn't work here. So what is the method that never fails? The quadratic formula, right? The quadratic formula always works. Likewise, completing the square. Now the quadratic formula is the condensed form or the simplified form of completing the square, right? So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac. This is the formula used to solve all quadratic equations, okay? If you don't know how to use any other method, this method always works, alright? Over 2a. Now in this problem, a is 1 because that has a coefficient of x squared. B is 2, that has a coefficient of x, and c is what? 2. Okay? Alright, we're going to plug in all these arguments here, and then we're going to solve, alright? So x is going to be negative 2 plus or minus the square root of b squared, 2 squared minus 4 times ac, and then that whole business divided by 2a. And then we're going to have, it's going to become minus 2 plus or minus the square root of 4. 4 times 2 is 8 minus 8 over 2. Okay? Now let's continue going. Minus 2 plus or minus 4 minus 8 is negative 4 over 2. Okay? So this now becomes minus 2 plus or minus, what is the square root of negative? Square root of negative is I, square root of 4 is 2, so this is going to become 2i. Okay, don't forget that I part. Over, so I can put this over 2, split it apart over 2. So if we divide, we're going to have minus 1 plus or minus I. Okay, so if we break them apart, we can have either minus 1 minus I or minus 1 plus I. Final answer for 38 is C. Okay? Alright, now let's move on to question number 39. Alright, 39 says, what are the solutions to the equation? What kind of equation is this? What on earth is this? 1 plus 1 over x squared equals 3 over x. Can I convert it into something I can work with? Is there something I can multiply everything by to get rid of the denominator? If I multiply everything by the LCD of the denominators, then that should clear the denominator out. Okay, so the LCD of x squared, x, and this has a 1 there. The LCD of all three of them is x squared, right? So the LCD is basically x squared. If I multiply everything by x squared, the denominators should be gone. Alright, so let's times this by x squared. This is a cleaning operation. Multiply everything by x squared. Okay? So we're going to have x squared plus x squared over x squared equals 3x squared over x. Okay? So this one just comes down as x squared. These are the identical, so just 1 equals 3. Remember the rules of exponents. Anytime you're dividing, you subtract the exponents. This has a 2. This has nothing, so put a 1. The smaller one has to go to the bigger one, so it's 2 minus 1. Okay, so we're going to have x squared plus 1 equals 3x. There. So before I can use any factorization method, the quadratic equation has to be in a standard form. So basically standard form is ax squared plus bx plus c equals 0. Or in other words, it has to be equal to 0. So let's make this equal to 0 by subtracting 3x from both sides, like that. So we're going to basically have x squared minus 3x plus 1 equals 0. Okay. Now we have something we can work with, something that looks more familiar. So look at all my options here. They're telling me that I shouldn't even try factoring by grouping because it's not going to work. It's telling me that the only option I have to use here basically is a quadratic formula. Okay, so what is a quadratic formula? X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, you can sing your song and get the formula, whatever works for you. So a basically is a coefficient of x squared, which is 1. If there's nothing, it's 1. B is negative 3. And c is 1. Okay, because that's basically the last number right there. So let's plug in these arguments into this equation and find out what the solutions to the equation is. So basically we have minus negative 3 plus or minus the square root of b squared minus 4ac, and then that whole business over 2a, which is 2 times 1. Okay. Alright, so with that in mind, we're going to have 3 plus or minus the square root of negative 3 squared is 9 minus 4 over 2. So we're going to have, let's split it apart. So it's going to be 3 over 2 plus or minus the square root of 9 minus 5 is basically the square root of 5 over 2. Hopefully I didn't confuse anybody here. So 9 minus 4 is 5, and then that's 3 over 2. Okay? Alright, so I just split it apart. Let's see. Do we have an answer yet? Oh yeah, we do. The answer for number 39 is basically A, because if we split it apart, x is going to be 3 over 2 minus 5 over 2, so root 5 over 2, and 3, and the plus side 3 over 2 plus root 5 over 2. Okay, oh gosh, I just did plus. Alright, so that's basically the answer. The answer for number 39 is A. Remember, we had to transform this into a quadratic equation by multiplying by the LCD of the denominators to get it solvable by the quadratic formula. Okay? So let's go ahead and do number 40. Alright, so for question 40, it says there are two numbers with the following properties. The second number is 3 more than the first number. The product of the two numbers is 9 more than their sum. Which of the following represents possible values of these two numbers? Let's see the first number is x. Okay, so let me write this. Let x be the first and y the second. Okay, alphabetical order. So the first statement says the second number is, remember, is equal, right? So y is 3 more than the first. So y is x plus 3. Okay, and then the product of the two is The product of the two is x times y, 9 more than your sum. Your sum is x plus y plus 9. Okay? So this is what the statements, these two statements in a algebraic form can be expressed like this. Okay, so let's test these options to see which of them satisfy both. Okay, it has to satisfy both in order for it to work. So for the A option, we have -6 and -3. This is the first one x, and this is the second one y. So let's do the test. Okay, all right, let's test it. Let's test the first condition. The first condition is the second one, -3. Is it equal to the first one plus 3? Is -3 equal to -6 plus 3? Is it? Put a question mark here. Is -3 equals -3 because -6 plus 3 is 3? Absolutely. So that checks out. Second one is the first times the second. -6 times -3. Is it equal to the first plus the second plus 9? Is that right? Is that true? -6 times -3 is 18. Positive 18 because minus times minus is plus. If I combine these two, the signs are the same. Add the signs is going to be -9 plus 9. The question is 18 equals 0? Is it? Absolutely not. Option A does not satisfy both, just the first. That's not sufficient. It must satisfy both. So option A is not the answer. So let's scrap A. A doesn't work. Okay, let's move along to B and test B. Okay, so for B, we have -4, -1. This is the x, and this is the y. Let's do the test, okay? We're going to test the first equation. So for the first one, the question is the second number equal the first number plus 3? Is -1 equals -4 plus 3? -1 equals -4 plus 3. Subtract and keep the sign of the bigger one. -1. Oh, that's good. Works out. Let's test the second equation. As the product of the two numbers, -4 times -1, is it equal to your sum, -4 plus -1 plus 9? Is that right? -4 times -1 is 4, because minus times minus is plus. And when I combine these two, -4 plus -1 is just add and keep the sign is -5 plus 9. Is 4 equal to 4? Absolutely. So B satisfies both equations, so my answer is B. I don't need to progress because that's the final result. Okay, so B is my answer. All right, thanks for paying attention to this clip. Do subscribe to my videos so that you can get the other parts of this preparation, and hopefully this gets you ready for your CST exams.